Okay, alright, so hello everyone, this is Chi and sorry if the video is fluctuating a little bit, because I'm holding this with one of my hand. So today we're going to talk about a mastering physics problem, question 2535, and here's the question. Okay, the two halves of the rod, which has, I'm not sure if you guys can see it, I marked out positive on the left hand side and negative on the right hand side. So the two halves of the rod in the figure are uniformly charged to positive Q. Alright, so this is positive Q. Although I know it's multiple lines, I didn't count exact number, but you guys know what I mean, right? So they're uniformly charged to positive or negative Q. Okay, and the question is, what is the electrical potential at the point, or at the point dot, or maybe I should mark it point P. What is the electrical potential at this point indicated? Alright, so first of all, when we read the question, I immediately noticed that the electrical potential is, because the question specifically mentioned it's uniformly charged, which means it has even amount of positive charge and even amount of negative charge distributed on this rod, which means if you take a specific point, or let's say a little tiny piece, infinitely small piece, and the amount of charge in this piece is going to be the same all the way across around on this rod. Yes. So to this one, in order to figure out what is the electrical potential at this point P, we have to recall that when we're in class, we mentioned specifically about the pattern of opposite charges, and also another pattern of same charges, which looks like an eye, like this. Alright, so in order to solve this question, we have to figure out the spot. This dot spot, the line, actually represent the spot of the point P according to that. So imagine this is this section, this part is representing this section of the rod. Since it's uniformly distributed on the rod, so that means on this point we're going to have a potential, right? Recall that we mentioned in class that on each line, any spot on the line, we're going to have same amount of potential, electrical potential. If you're on this line, the dot on this line, let's say dot 1, is going to be having the same potential as dot 2, even though they're in different positions, but they are still on the same line, so they are having the same amount of voltage, electrical potential, sorry. Okay, it's focused. Right. So, saying that, we are trying to figure out the electrical potential at this invisible line, which is assuming that's exactly in the center of the rod. And recall that the electrical potential, while we were doing the charges with fixed two charges on a line, on a linear line, right? When we're trying to put an electron or proton, doesn't matter, moving towards this direction, towards the proton or the electron to the right, remember the graph of the charge goes like this. which means let's say imagine this is a rod. Let's say imagine this is corresponding to the rod we had before. On this piece, we're looking at the charge, what would happen. That means at this point, it goes from positive to negative charge, which means there has to be a zero, because from positive infinity goes to negative infinity, there has to be a point where the electrical potential equals to zero, which happened to be right in the middle, because we have a positive charge Q on the left hand side, and we should have a negatively charged Q on the right hand side. The amount of charge is exactly the same, and the rod is evenly distributed. The charge is uniformly distributed. Sorry, it's the same thing. You guys know what I'm talking about. So that's why right at the center point at dot P, the electrical potential is equal to the line over here. That's having the same amount of electric potential that equals to zero. And that is correct. Alright, so by saying so, let's say if we have a unevenly distributed rod, I mean, I know it's a little bit extra, but I'm just curious. If we have an unevenly distributed charge with positive and negative, but it's not evenly distributed, it will still have a 0-volt charge or point on that rod. But yeah, this is it. I know it's a little bit extra, but yeah, I hope you guys can understand what I'm talking about. Hopefully, fingers crossed. And yes, that's it. All right, thank you.